Hello everyone, I am Jivnes Sandhan from IIT Kanpur. I will be presenting SanskritShala, a neural Sanskrit NLP toolkit with web-based interface for pedagogical and annotation purposes. This is a joint work with co-authors from IIT Kharagpur and IIT Mandi. Why Sanskrit? Sanskrit is a cultural heritage of India. It contains extant manuscript numbering over 30 million, and laudable efforts have been put in digitalization. However, we find its limited usability due to the lack of language expertise. For example, given a text in Sanskrit, how to tokenize it into the meaningful padas or meaningful candidate words. Given a compound word in Sanskrit, how to identify the semantic type relation between the components of a compound. In this scenario, there are two possible ambiguities are there, and dependency relations. So how to identify the dependencies between the words. Each association will give a different possible interpretation. In order to facilitate the grammatical support from computational side, so there are several efforts have been put in literature, such as there is a rule-based engine called Sanskrit Heritage Reader, where the shallow parser is provided to enumerate the potential candidate solution for the word segmentation as well as the morphological analysis. There is another work called Samsadhani, where the rule-based systems are available for various tasks such as dependency parsing, where the Paninian grammar is leveraged in order to provide the possible solution space for the dependency parsing. Therefore, in this work, we investigated how can we utilize deep learning to provide the ease for making Sanskrit text more accessible. So earlier attempts were mostly rule-based approaches. This is the first time we are providing the data-driven approach to facilitate the linguistic analysis. So our overall contributions in this work as follows. We propose the linguistically informed neural architecture for various tasks such as word segmentation, compound type identification, morphological analysis, and dependency parsing. Our architecture performs the state-of-the-art performance on available benchmark dataset for Sanskrit. We also release the various resources such as pre-training word embeddings for intrinsic task test beds to assess the quality of the proposed pre-training embeddings. And finally, we release the SanskritShala web-based toolkit for annotation and pedagogical purposes. For all our system, code base and datasets are publicly available. Now let me briefly talk about the different architectures that we propose. The first task is the Sanskrit tokenization, where the rule-based sequence labeling architecture, which is the character level prediction architecture, is integrated with the potential candidate solutions obtained from the shallow parser. So here SHR is used to get the potential candidate solution, and these candidate solutions are integrated with the architecture. So that's why this architecture is also called as a linguistically informed transformer-based architecture translist. In the next task, we tackle the morphological analysis task, where the multitasking system is used, lemma tag, and two tasks are coupled. Morphological prediction, where each category of morphology is being predicted, along with the lemma prediction task, where the different character level module is used, and this is the multitasking setup. And our proposed system stood first in the hackathon competition organized for this task. Next task is dependency parsing. So we propose the pre-training called LCM, which is useful for the languages which are not covered in pre-training of the LLMs. So along with this proposed pre-training, we also ensemble the different strategies specifically tailored for the low resource settings such as data augmentation, self-training, transfer learning, and multitasking. So this is our ensemble architecture. Using this ensemble architecture, we were able to outperform the linguistically inform where rule-based system is coupled with a data-driven system. So this hybrid system was the state of the art. So we were able to outperform simply using the purely engineering based approach. So this is dependency parsing. And final module is the compound type identification where we propose the context sensitive architecture. So this is the compound word along with context is also used. So this context is helpful for the prediction of the category of semantic type, and this is the multitasking architecture where the dependency parsing and morphological prediction task is coupled. And here in order to facilitate the naive users to get the understanding of the proposed architecture or to use without having any prior expertise in a deep learning, we provided the web-based toolkit called SanskritShala where the different modules are integrated. So now we'll briefly see its demo and working. SanskritShala, the Neural Sanskrit Toolkit, facilitates computational linguistic analysis for NLP application. It is also integrated with the rule-based chatbot to automate simple and repetitive user queries like answering frequently asked questions. Let us move to the first module, word segmentation. Give unsegmented string as an input with appropriate transliteration scheme. From the candidate solution space, our predicted solution is shown with yellow highlight. Now let us select the correct solution with the help of our system's prediction. The user is also allowed to see the final selected solution. If needed, he can also download it. Now let us take one more example for segmentation module. Ramo Vanam Gachati means Ram goes to forest. Now let us move to the next module, morphological tagging, for the same example. From the SHR candidate solution, our predicted solution is shown in green color. A user is also allowed to add the correct tag if it is not present in a candidate solution. Now let us move to dependency tagging module. It loads the predicted dependency tree from our pre-trained model and allows user to correct misprediction using our interactive interface. Here we present the final module, compound identifier. Give an input in proper transliteration scheme. The semantic class is Bahurihi. If we simply change the context, then the semantic class changes to Tatpurush. We are also planning to track Sanskrit NLP progress to give overview of dataset and state of the art. We appreciate your feedback. Thank you.